As we keep moving through our presentation, I would like to experiment with this diffuse light calculation in Vertex Shader. So let's download and get started with the Laboratory 7 Diffuse and Specular Light. And here our plan is to compose data for material of an object by providing different colors for each of the lighting components and pass that information to our shaders to compute the light. So set things up. We need to download the project prototype. And of course, I'm going to download under Labs subfolder and unzip it right here. So save. Okay. So this is the file. I'm just going to unzip it. And we can now open this project in Visual Studio. Upgrade to the latest version of the compiler. Okay, and we can try building it. So let's take a look at the updates that took place since the last time we experimented with light calculation in our shaders. So we definitely need to open the new shader code. So this is the vertex shader, and this is the fragment shader. And in the vertex shader, we definitely have new uniform, which is a vector of 4 components that is specifying the position of the light source in our world. And we also have a new uniform variable where we pass to this shader the matrix that contains all rotations for our object, and we're going to use this matrix to transform the normals. You would imagine as we take our object and if we need to rotate it. Okay, so if we have this object and it has some normal vectors specified for every vertex, right? So for every vertex we specify the normals that are perpendicular to the surface of the triangle in which it resides. So if we start rotating this, okay, we try to rotate this model, then of course we also have to rotate the vectors that are our normal vectors. But at the same time, we don't want to apply scaling and translation of normals in space. We only need rotations. So the way we're going to calculate this matrix is that we're going to take our model matrix, which includes all of the transformations of our object, and only extract rotations out of this model matrix. And that's the way the rotation matrix is going to be generated. So we're going to see this later on in our CPU main program. The rest of this shader code we're going to discuss in our next video. But for now, let's just open the model class. All right, the declaration of our model class, and that's of course under the source subfolder in our project directory. And here we have the model class header file. The model class now includes new member function setMaterial, which accepts the parameters for ambient, diffuse, and specular light. And these are going to be just simple 3-component arrays, like red, green, and blue components for these material properties. In addition, we have a new header file for the light class. So now we're going to have a new class in the system that is responsible for storing the properties of the source of light. This is the copy of the rotation matrix that we discussed earlier. And we now also have pointers to the material colors that we're going to set up before using the model. So this is an update to the previous version of the model class. And since we're now going to be passing the new rotation matrix to the shader, we're also going to support its unique handle identifier that we will query from the compiled shader program. In the implementation of the model class, in the rendering function, this is where we set the material. We just simply generate space for the new color components. But in the rendering function in the model class implementation, this is where we check for the material properties being set in the model. And if that's the case, we're going to take the light object and combine its ambient property with the model material ambient property. And so we're going to do this for both diffuse and specular components of the light as well. And this is what we're going to call combine ambient and diffuse and specular colors, because if we have an object and we decided to provide the material properties, these colors, ambient, diffuse, and specular colors that we chose for our object, and now we also have the source of light. So here we can also decide that the light has a specific color, right? It can be white, yellow, green, blue, anything you like. And so now we can combine this with the material properties to come up with this combined ambient, diffuse, and specular colors that we can upload to the shader to use when it does its light computation. And this computation is actually done in the fragment shader. So these three uniforms for ambient, diffuse, and specular correspond to our efforts right here to set them up when our object is rendered. So these uniforms are passed to our fragment shader right here. And we also use the shininess for the specular light, which we will discuss a little bit later on. So here we have the new header file for the light class. Let's take a look at that. So this is our light, and it has position, ambient color, diffuse color, specular color, and it also uses pointer to the shader object, because if the light position changes from one frame of display to another, we have to update the position in our shader. The implementation of the light class in file light.cpp includes light object constructor, which allocates dynamically space for the position, the ambient, diffuse, and specular properties of the light colors, and then simply copies the information that we provide to the constructor into these dynamically allocated arrays in this loop. We also have to have access to the shader object, and when the position of the light changes, we update the position, but also we call this member function to update the light position in the shader. And this is the uniform which is present in our vertex shader. So right here we have a vector of 4 components, and this is specifying the light position. So this is the responsibility of the light object implementation, where it's updating information in its set shader light position member function. So now a quick summary about our updates. Vertex shader includes light position. Alright, so it's right here. The light C++ class has new code to handle the light source properties. The render function of the main driver program right here at the end of its rendering function makes this call into the light object to set shader light position. So this is the new update in our main implementation file. The model rendering we already reviewed. It combines all of the light components and uploads them to OpenGL. And the vertex code implementation I would like to discuss in our next video, But for now, let's just run the quick demonstration of how it works. So I'm just going to say debug, start without debugging. And you can see the impression of diffuse and specular light components calculated in this animation. And it makes an impression like this is a car model made out of some sort of plastic material with this green color.